Okay, so we are going to be talking about some probability here and how to find it in this lesson. So, our goals for today are to be able to calculate the theoretical probability as well as the empirical probability of an event. And it's okay if you don't know what that means, we will get there in just a minute. So, empirical probability is the probability that you find when you observe experiments, and theoretical probability is the probability that's found mathematically. So we can find the probability of anything using math. That's its theoretical probability. The empirical probability is how often does it actually happen when we roll the dice 5 times or flip a coin 20 times or whatever. Okay. So they're two very similar things, but not the same. So here we have a class that rolled 2 dice 150 times and they got these results. Okay, so they rolled a 2 3 times, 3 5 times, 13 times they rolled a 4, 36 times they rolled a 7, 4 times they rolled a 12, etc. Do these look like what you would think or what you would expect? Kind of makes sense about the 7, right? Because if you think about all the different ways you can get a 7 with 2 die, 1 and 6, 2 and 5, 3 and 4, 4 and 3, 5 and 2, 6 and 1. There's a lot more options for getting a 7 than there is for any other number. So it makes sense that that would be higher. I found the 11, on the 8 to be interesting because I would expect to see the 8 be higher than that. That's where theoretical and empirical kind of separate. Theoretically, the probability of rolling an 8 should be higher than rolling a 9 because there's more ways to get 8, or especially like a 10. And yet they were the same. So the empirical probability played out to be a little bit different. So if we were going to do this, we could, fill in this table and figure all this stuff out. So let's say, sorry, I don't know what this is here. If we're looking at the total number of 2s rolled, how many? Well, they rolled 3 out of 150. If we write that as a fraction, we get this, right? 3 out of 150. And then the percent we take, we find by dividing 3 divided by 150. And that's 0.02 or 2%, okay? And we can do this for any of these values. So here I've got them all figured out so you can kind of see. Now, most of the time you can see we're going to reduce this, right? Okay, so the 3 over 150, we actually would reduce down to 1 over 50. The 3s were rolled 5 times out of 150, which reduces to 1 out of 30, etc. And then you can kind of see each of these percentages as we sort of go through and figure it out. Okay, so just to talk about how to mathematically figure that out, we can do that using our numbers. Divide the number of outcomes by the total, and then you can get both the fraction and the percent for that. Based on the observations that we saw, what is the probability that the next roll will be a 9? Well, let's look. You have a 4 out of 25 chance, or a 16%, that the next one is going to be a 9. If you were to make a bet on the next roll, which number would you place your money on? Now, that one's a little bit of a thinker, okay? I like a safe bet, so I'm probably going to go with a 7 because that's a safe bet, and it has the highest percentage of happening, okay? Maybe you like to take a risk and you're going to go for a 2 because that had the lowest percentage. Everybody's a little bit different in how they would look at this stuff, but a sure bet, quote unquote, is going to be the one that has the highest likelihood of happening. When we talk about sample spaces, remember we list them all out. Now, again, I'm not going to make you do that, but here are the total different options that you can get when you're rolling 2 dice. A 1, a 1, a 2, a 1, etc. Okay, and notice they're different colors to kind of help you see which one rolls which way. There are 36 total possibilities when you're rolling 2 dice, and we can use our probability out of 36 to figure out how likely it is to roll something. So to figure out the theoretical probability, we're going to use that sample space. How many ways can you get a 2? Well, there's only one, right? You can get a 1 and a 1. So you have a 1 out of 36 chance of getting a 2. A 3, you would have 1, 2 possibilities. Make sure there's no more here. Sorry, my computer's on the fritz a little bit. So it'd be 2 out of 36, okay? And you can kind of see I filled all these in. A 4 would be 3 out of 36. 5 would be a 4 out of 36. 6 would be a 5 out of 36, etc. And notice it gets to 7. That one's the highest. And then you start going back down. Now, this looks a little different than our empirical one because this is the theoretical or mathematical or pure probability. And the empirical one is the observed probability, which does not always play out exactly like the theoretical. The more experiments you do, however, the closer it should get to the theoretical probability. So ideally, if you did 100 rolls of the 2 dice, your numbers or your results should look much closer to this, or 1,000 or 1,000,000. The more you do, the closer it should get to the theoretical probability. So I want you to think about, what did you notice about the probability of rolling each value and what you kind of think about the empirical versus the theoretical. Why do you think they're different? And what do you think would make them be the same? Or is it just a fluke? Or what do you think about that? Okay, I kind of want you to just think about that. So finding theoretical probability, you take the number of ways an event can occur divided by the total number of possibilities. The important piece of this is that theoretical is figured out before the event happens. Empirical probability, you divide the number of times the event happened by the total number of times you did the experiment. And that has to be done after the event happens, okay? So theoretical comes first, and then empirical is sort of your data from your experiment. Given a well-shuffled deck of cards, what's the theoretical probability of drawing a face card? Well, there are 12 face cards in the deck, and there are 52 cards total. So the answer would be 12 out of 52. If we can get this written here, okay? So you'd have a 12 out of 52 chance, which reduces to a 3 out of 13 chance. A 10, how many 10s are there in the deck? There's 4 out of 52, which is 1/13. There are 13 diamonds. I had to think about that one for a minute. Out of the 52 cards, which gives you a 1 in 4 chance of pulling a diamond. Now, empirically, is that what's going to happen if you perform an experiment? In 12 cards, or in 13 cards, 3 of them are going to be face cards, or every 4th card is going to be a diamond? Not necessarily, okay? This is the theoretical probability. The empirical, once you do it, oftentimes is different. Now, the more often you do it or the more times you perform the event, it should get closer to that theoretical. Hopefully, but not always. There's always that probability of it changing. Now, if we were to do a lab and find the empirical, so if we had a deck of cards, we could count how many times a face card comes up, how many times a 10 comes up, and then that would be our empirical probability. So let's say, in the first 3 cards you draw, one of them is a face card. That's a 1 in 3, which is very different than the 3 in 13 that we had before. So it just kind of depends. And empirical is what you get when you are performing the experiments. Okay, so hopefully you feel like you can find both the theoretical and the empirical probability of an event. We're going to do a little bit of practice with that, and that is what your assignment is today.